Peninsula, New Zealand, where Electron is approximately 15 minutes from launch. Both the launch vehicle and weather are currently green as we head into the final minutes of the launch countdown. While we are working through some final verifications for launch, there's a chance that we could hold at L-12 minutes if the team needs additional time, in the event that we could ensure today's flight is a success. As the name of our launch implies, today's flight is part of an intensive test program for Electron. In the event that we do encounter any issues throughout the launch, Rocket Lab will end the webcast while our team works through the data, and any updates will be provided via our website and social media.
Yo.
Rangers go for launch.
FSO.
FSOs go for launch.
T1.
T1 is go for launch.
ComOps.
Go.
MNet. Executive.
Your executive is go.
Copy that, sir. And LC, this is flight on mission cord. Open your MCC launch switch cover and confirm.
Confirm.
RCO, this is flight on mission cord. Open the Mahia launch cover switch and confirm.
Switch is up.
Copy that.
And RF, this LC on mission code, increase S-band power to flight level and confirm. A3900.
And VMS, this is flight. We're going to continue to count.
Copy.
As you just heard a few minutes ago, now that we have a go from all team members, the count will proceed, including the retraction of the launch tower strongback, a transition from ground to internal launch vehicle power, and the start of the final launch auto sequence.
In all stations, this is flight on mission.
On its maiden flight
on my mark,
in May of this year, Electron successfully reached space. And today we'll be building on our test campaign by not only reaching orbit, but deploying customer payloads as well. On board Electron are spacecraft from Planet, who specializes in Earth imaging, as well as Spire Global, whose spacecraft focus on weather and ship tracking. Today's launch is contributing to Rocket Lab's mission to open access to space to better understand our planet and improve life on it. Today's launch is a significant step towards that goal.
S-band is on planet.
Rangers in terminal mode. Opening top clamp.
Top clamp open, proceeding with strong back retract.
VMS, LC on mission core.
Go LC.
Please confirm all separation events are armed.
Confirmed.
Battery LC on mission core.
Go ahead.
Please confirm stage 2 battery hot swap is ready.
Confirmed.
Confirm the hot swap is from stage 2 HVB2 to stage 2 HVB3.
Confirmed.
Confirm stage 2 HVB1 and HVB2 are enabled and HVB3 is disabled.
Confirmed.
Confirm all stage 1 HVBATs are enabled.
Confirmed.
Stage 2 LC on mission core.
Go LC.
Confirm stage 2 engine is ready.
Stage 2 engine is ready.
Confirm igniter pressures are good.
Igniter pressures are good.
Confirm Curie catalyst preheater is off.
Confirmed.
Stage 1 LC on mission core. Please confirm all stage 1 engines are ready.
Confirm stage 1 engines ready.
And confirm with range igniter pressures are good.
Confirmed.
Strong back retracted.
As you've just seen, the launch vehicle strongback has retracted, getting us even closer to today's launch. While we wait here for the next 8.5 minutes, let me share a few details on the launch vehicle itself. As the world's only operational, fully carbon composite launch vehicle, Electron stands at 17 meters tall and has a diameter of 1.2 meters. The vehicle is powered by our Rutherford series of engines, which are built in-house utilizing advanced 3D printing manufacturing techniques. The Rutherford is also the only engine to utilize electrically driven pumps in place of more complex turbopumps, another example of Rocket Lab's innovative approach to rocket design. During the first few minutes of flight, a total of 9 Rutherfords will power the first stage of the vehicle, followed shortly thereafter by the separation of Stage 2 and the ignition of a vacuum-optimized Rutherford, which will propel the vehicle the rest of the way into orbit. Once there, Electron will deploy our customer payloads from Planet and Spire, utilizing our own line of CubeSat dispensers, which we call Maxwell. Today's flight will take us on a trajectory to an 83-degree inclination orbit, with an orbit insertion altitude of 300 kilometers by 500 kilometers. During the flight, there are a number of key events that will occur on our way to orbit, most of which will be visible during our web stream. First, following the successful ignition of the Rutherford engines, the launch vehicle hold downs will be released, allowing Electron to climb up and away from the launch pad. The vehicle will pass through max Q, or maximum dynamic pressure, when the forces on the vehicle are at their greatest, at around 1 minute and 16 seconds in the launch. The stage will continue for another 1 minute, followed by shutdown and stage 1-2 separation. Stage 2 will then ignite, and its single Rutherford engine will burn for nearly 6 minutes, during which time the fairing will be deployed, which up to this point had been protecting the payloads during the earlier phases of flight. When Stage 2 shuts down, we'll have reached our elliptical target orbit and perform deployment of our customer payloads. At this point, the webcast will conclude, and any further updates will be provided via our website and social media streams.
Battery LC on mission core.
Go ahead, LC.
Confirm TVC batteries charging is disabled.
Confirmed.
And RCO, LC on mission core.
Go ahead, LC.
Switch off FTS ground power and confirm.
Power lock disabled. FTS power is down.
FSO, LC on mission core.
FSO.
FTS is on internal power. Check tone should be continuous from now.
Roger that. And failsafe is enabled.
And FTS, you confirm that FTS failsafe is enabled?
Failsafe is enabled.
And confirm FTS is green on internal power.
FTS is green and on internal power.
While we've talked about what we're going to do during the launch, there's been a concentrated effort of work to get to this point. Teams from both the United States and New Zealand have spent countless hours preparing for today's launch across areas of design, manufacturing, assembly, testing, and mission analysis. Once the vehicle arrives at the launch range, it currently takes approximately 4 weeks to prepare the vehicle, install payloads, and perform final tests prior to launch. These processing times will decrease as our launch rate accelerates. In the final days before launch, Electron takes part in what we call a wet dress rehearsal, where the vehicle is fueled but not fired, giving our operators a final high-fidelity practice run at what launch day will be like. In the final 24 hours prior to launch, the vehicle is rolled out to the pad, taking vertical and fueled with the kerosene and liquid oxygen propellants that will feed the engines as they carry Electron up into orbit. While today is Electron's second launch, Rocket Lab expects to quickly ramp up into a regular launch cadence, with vehicles already in production to support a full 2018 launch manifest.
AV-BET charging disabled.
RCO flight mission cord.
Flight, this is RCO.
Yeah, your status. Copy. FSO flight.
FSO is green.
Copy. FSO is green.
Avionics LC on mission code.
Go ahead, LC.
Move stage 3 AV-BATs to internal power.
LC vehicle or stage 3 is on internal power with flight mode enabled.
Okay, you confirm flight mode is enabled. Flight, vehicle is ready.
Flight copies. VMS is flight. Go for auto sequence start at T-minus 2 minutes. Again, go for auto sequence start at 2 minutes.
Copy, auto sequence locked.
As you've just heard, we are go for the auto sequence with the last 2 minutes before launch. At this point, we're going to pause our commentary and listen in to launch vehicle operations and the final count.
Entering auto sequence.
Avionics, confirm all AV-BATs have been switched to internal power.
Confirmed.
RCO, confirm that the ground power has been disabled on all 3 stages.
Ground power has been disabled.
Okay, to all operator, vehicle is on internal power. Waiting for locks press.
Locks pressing.
Stage 2 locks pressed.
Stage 1 pressed.
Pressing Kero. Fast purge enabled.
Stage 2 Kero pressed.
Can confirm fast purge enabled.
T-minus 45.
Deluge on.
Can confirm deluge active.
T-minus 30.
Setting GNC states. Readying
T-minus 20.
engines.
T-minus 15. 10, 9, 8, 7, 6, 5, 4, 3,
Ignition.
2, 0.
Abort. Keep to schedule.
Abort.
RCO confirm stage 1 umbilical is still in.
Umbilical's in. Power's all up.
Stage 1 confirm all stage 1 engine are e-stop.
Confirm stage 1 engines e-stop.
And reset all stage 1 engine and confirm.
Confirm stage 1 engines reset.
Confirm that the carrier tank pressure is down to 150 kPa. And carrier vent is closed. Keep stage 1 locks pressed.
This is Mission Control Auckland. As you can see, the vehicle has had an abort during the launch auto sequence. At this stage of flight, the vehicle flight computer is actively monitoring a wide range of vehicle performance parameters. And when any of these parameters are violated, the vehicle determines that it's not ready for flight and holds the count. An abort can be performed at any point up to the release of the vehicle hold-down clamps, which nominally release a few seconds after initial engine ignition, which we did see. Right now, the team in Mission Control is reviewing the data, so we'll stand by while we learn if we'll be able to make another launch attempt today, with the time remaining in the window.
Re-engaging strong back.
RCO, LC on mission call.
Go ahead, LC.
Can you please confirm that the FTS ground power is enabled?
Ground power is up. Power lock enabled.
And confirm stage 1, stage 2, and stage 3 ground power is enabled.
Stage 1, stage 2, stage 3 enabled, and power lock is up.
Thank you. FTS disabled, FTS failsafe, and confirm.
Stand by. Confirmed.
Okay, and confirm FTS is back on external power.
FTS confirms.
Okay, avionics LC on mission code. Please bring the entire launch vehicle to external power and confirm. Stage 1, stage 2, stage 3, and FTS.
Vehicle is back on external power and charging.
Battery LC on mission code.
Go ahead.
Please re-enable TVC batteries and charging.
TVC's charging.
And RCO holding for your confirmation that the strong back has been enabled.
Strong back re-enabled. Re-engaged, sorry. Top clamp currently in work.
VMS LC on mission code.
Go LC.
Confirm all separation events are disarmed.
Confirmed. RF LC on mission code.
LCRF.
Please decrease the S-band power to ground level and confirm.
Copy. Decreasing.
Flight LC vehicle is secured on the pad. Strong back re-engaged. Top clamp re-engaged.
Yeah, in all stations, this is flight. We are scrubbed for the day. LC and RCO are going to go through LOX D-tank at this time.
Copy.
As you've heard, after reviewing the telemetry and the data and the time remaining in our launch window, the team has decided to wave off for the rest of the day. Information on the next launch opportunity and webcast details will be shared on our website and social media feeds. Thanks for tuning in today's launch attempt, and we look forward to seeing you again soon.